You've no doubt heard us say a few times now that NQL is SQL for JSON. In this lesson, you'll see precisely how true this is. A NQL query looks very much like a SQL query. The difference is you are querying document fields within a bucket instead of columns in a table. You have all the filtering power you expect from SQL, along with aggregations, functions, subqueries, and more, as well as new behaviors specific to JSON, such as nesting and unnesting multidimensional fields within documents. A query might look like this. Give me 3 specific fields from my customer documents where year-to-date sales are filtered within a range, and then order the results by name. Of course, while ad hoc querying is supported, you'll want to create appropriate indexes to optimize the speed of commonly used queries. As you can see, the way you do it is easy and familiar, to anyone used to working with SQL at least. The resulting indexes are maintained, lock-free and in-memory if you choose, by the index service. You can easily review the state and definition of all current indexes from the Indexes view in the Couchbase UI. As you've seen in demos, NQL queries can be developed and tested in the Query Workbench within the UI. This tool supports code highlighting, schema introspection, visual query plans, query history, query statement import, and the export of query results. Or, if you're the command line type, and you know who you are, you can alternately use CBQ, which is also a thorough NQL tool, and allows you to control output in case you want to work with piping queries and results. So a good place to begin a comparison of SQL and NQL is with the basics: create, read, update, and delete. Because there actually is a slight difference here between SQL Server and Couchbase. Couchbase is fundamentally a key value system. When you create a document with an insert statement, you provide a key, as you see here, along with a value, which would normally be a JSON document. NQL lets you build the JSON inline or call for it externally. Whether you would also add this key to the document itself, as shown, touches on broader data modeling issues, but it wouldn't be necessary, as document keys are accessible in NQL via the meta function. Read operations are syntactically identical in many respects, except that you are selecting document fields from a bucket, likely filtered by document type, rather than columns from a table. As you'll also see, filtering and indexing are very similar to what you already know. Update operations are likewise similar, with the added flexibility of upsert operations. In NQL, an update will err if a record does not exist, while an upsert, for speed and efficiency reasons, because we're all about scale, performs either an insert or update as needed. Delete operations are syntactically virtually identical also. Filter for a document or documents from a bucket and delete them. There is a nuance in NQL syntax, though, resulting from the fact that JSON documents are string documents, interpreted as such. In SQL, if you are, for some reason, working with punctuated table names, you would quote them in a from clause. JSON, however, relies on single or double quotes to identify string literals. As a result of this, if you are, again for some reason, working with punctuated bucket or field names, you surround those elements with backticks and not quotes. String values in the same query would be single or double quoted. Just be consistent. Enforcing a strict data schema on every write operation makes sense for systems of record, where long-term schematic stability is a primary concern. Couchbase focuses on agility and scalability instead. JSON documents can evolve however needed to support rapidly evolving software focused on innovative systems of engagement. So in a NQL query, any given field may have a value, or be physically present yet have no value. A field may physically exist or be missing, and a field may be explicitly null or not. Your data model can evolve however your object models require. As they say, a picture's worth 1,000 words, so let's jump in and take a look at some of the features of Query Workbench and get started running some queries. So over here on the dashboard, I'll click to the Query view, and the first thing that jumps out at me here is that our Customer 360 bucket is non-indexed. That means I can't execute any query against it. I need to have at least a primary index. So let's create one. I'll go to the query editor and I'll start typing in the word create and then use my tab key to complete that. I want to create a primary index, which I will name def customer 360 primary on the customer 360 bucket. End it with a semicolon so I can hit enter to execute it. And there we go. We've created the primary index. If I go over to the indexes view, we'll see it appear here. I could see the definition. I could open it to edit and rerun it. I could also drop the index from here. I'll go back over to the query workbench. I'm going to switch over to JSON view. You don't get any results back from running a create primary index statement, but I'm now able to do some querying. I want to run a select query, and to keep it super simple here, I'm going to select all fields from the customer 360 bucket, and I'll limit total results to 10. And I get back 10 JSON documents of this customer type we've been working with. Now notice that the results come back as a JSON array of nested JSON objects where each object represents one document. And remember that these particular customer type documents that we're working with have a nested billing address object within them. So it's not just a list of scalar values like a tabular record. In fact, we can visualize this over here in the table view. We see that billing address has subheadings under it for each of the fields of the nested object. But other values, like created email, first name, etc., do just have scalar values, and as we've said previously, if you have like name fields in successive documents, how different is that really from a column in a table as we see here? But let's go a bit further with this and play with a bit of filtering. Now I'm going to go back to the document, and I could filter by any top level value by just referring to it like any other column name. But we're working with multidimensional values here. I want to filter by this city value inside a billing address. So I'm sure you can imagine where this will go. I'm going to add a where clause, and I want to filter not just by billing address, but by a particular value nested within it. I want to pull back any city where the name of the city appears in a list of values. I also don't want to select all fields. I'm going to select the entire billing address object and perhaps the username. Go ahead and execute my query, and I see I get 6 documents back, and the documents that come back from the query contain just the billing address object and just the username. So 6 objects, again, returning in a JSON array. As a table, it might look like this. There we see the cities that we've selected for. Now, if I wanted to see the plan for this particular query, I can click here, and amongst other things you could determine from this, you could see that we're relying solely on a primary index scan. The name of the index that we are relying on is available here. In the next lesson, we'll look a bit further at creating more specific indexes for our queries. The last thing to look at here in terms of the query is some of these filtering capabilities that we saw. Because this is JSON, not a table, it's possible that a model has evolved in a way that some documents have a field and some don't. So let's see if any of our documents are missing the city field. Turns out no. Across our entire bucket, there are no documents that have the city field missing. But has it been left null perhaps in any of our documents? I'm going to take my limit off of this because there are a few I happen to know. Execute this, and we'll see that yes, there's actually 560 documents where the city field is defined, but the value is explicitly null. Notably though, when we display this as a table in Query Workbench, I lose the distinction between whether it's missing or null. Ultimately, these are JSON documents. You can jump in and see those distinctions here when you work with them as documents. The very last thing for this demo is just to note up here in the corner, I could export my query results as JSON, I could export them as tab-separated values, and I could export the query statement itself. I also have the option to import a query statement into Query Workbench. Data import, as we've already seen, would happen with the CB import tool. So what have you learned? Query Workbench supports syntax highlighting, schema introspection, tabular data display, visual query plans, statement import and export, along with data export. NQL, insert, select, update, and delete operations are very closely analogous to their SQL counterparts. Punctuated artifact names are backticked in NQL. And NQL can logically handle whether a field is valued, missing, or null. So again, you could dive into the labs now, if you haven't already, to get your hands on some NQL queries, or stick with the videos. Next up, we're going to compare data types, transactional control, and atomicity. Come on back.